Okay, the second type of compound inequality that we're going to look at today is compound and. So same idea. What would we say the definition of the word and is? Presley?
Like addition.
Right, yeah, so in math we do often use that as addition. What does it mean just like this in an English term? You're exactly right. Let's take the math out of it for a moment.
To do both.
To get both. Right, so compound and we're talking about getting both of them. Okay, if you go to the grocery store with the intention of buying eggs and milk, and you only leave with eggs, you did not get what you were supposed to get. Why eggs? I don't know. Eggs and milk are always a bad example. Who really just buys eggs and milk? But whatever. Okay, so we're getting both of them. Compound and gets much more complicated. Okay. We do have a simple aspect of it sometimes. Sometimes we're lucky and compound inequalities will be written just like the compound or. So sometimes we'll have something that says x is greater than or equal to 5 and x is less than 7. This is not the norm. But if we are lucky and we see something in this format, we are going to treat this just like we did the compound or. Right? We're still going to put two numbers on our number line where we make sure our smaller number is on the left. And we're going to graph them both above the number line individually. Okay, so open or filled in circle at 5. Filled in. To the right or to the left? To the right. Open or filled in at 7. Open. To the right or to the left? Okay, but now that we're talking about compound and, we want to graph anywhere that when they fall, we see both of them. Okay, so if we look here and these fall down, right, we only see the green to the left. We only see the red to the right. But in the middle, we see both of them. Okay, so that's the part that we'll bring down onto our number line. So I was saying this to some of you, make sure your actual circles come down with it. Right, so we still need that open and filled in circle. Okay, the complication with compound and is that we often do not see this as two separate inequalities. The majority of the time, instead, they will be sort of squeezed together into one big piece. Very similar to the English language, right? I could say, Joe went to the store, period. Joe went to the park. Or I could say, Joe went to the store and the park and just squeeze them together in one thing. And that's exactly what we can do with compound inequalities. So you can just put them into one big piece. So instead, we might see something that says, three is less than y, which is less than or equal to 10. Now, I can tell you right now, I'm going to show you a little bit of a different thought process than you may have previously seen in other math classes. Okay, I don't teach it this way on other occasions, but we've already seen the other way. So if you want to do ways that you've seen before, I have no problem with it. Okay? However, when this y is in the middle, technically what this says is y is in between 3 and 10. So the only thing you need to check is to make sure the inequality statement is true. So if we're going across, is 3 consistently less than 10? Is that a true statement? Yes. If that is a true statement, you don't need to do any of the other stuff. You can just go straight to your number line and know that this says 3 with an open circle, 10 with a filled in circle, and y is in between those two numbers. Right? That's what that says. Y is in between 3 and 10. So let me show you what I mean by that being a consistently true statement. This one says 8 is greater than x, which is greater than or equal to 12. Okay, so let's check if this is a consistently true statement. Is 8 greater than 12? No. So this is a false statement. So what would our answer be? There's nothing we can do. Okay, if it's a true statement and we know we can graph it in between, we know we can graph it in between. We don't need to do any of the graphing above and then bringing it down because y is already in the middle. If it is a false statement, 8 is not greater than 12. It's just a no solution. Are we okay there? Okay, the bigger problem is then being able to solve these. Okay, this is a compound inequality because we have 2 inequality symbols. This is compound and because we don't see anything at all. With or, we always read the word or. If we see the word and, it's an and. If we don't see anything, it's an and. Okay. With a compound inequality, again, that means we have multiple inequalities happening at the same time. So what we're going to do is we're going to kind of pretend for a moment that we only see one inequality. So we're going to pretend, I'm going to cover all this stuff up until we get just past the first inequality symbol. No more, no less. Okay, I'm going to work until I get just past the first inequality symbol and only look at the inequality that now makes sense. Agreed? Right, 2x is less than or equal to 18 is something that we know how to solve. What would we do to solve this? Divide by 2. Now, here's the deal. If we're going to divide by 2 on one side, we have to divide by 2 on the other side, except now we kind of have 3 sides. So now not only are we going to divide by 2 and divide by 2, but we are also going to divide by 2. All 3 places. Okay, so whatever we do to one side of the equal sign, we do to the other. But now that we have multiple symbols, whatever we do to one side, we do to all the other sides. Okay, so 6 divided by 2 is 3. Our 2's canceled, just like they would with any equation we solve. 18 divided by 2 is 9. So let's check. Is this true? Is 3 less than 9? Yes. So when we go to graph this, open or filled in at 3, Open. Opener filled in at 9. And we're going to fill in the middle. Why are we filling in the middle? Because X is in between 3 and 9. We got a true statement, and we visually see X in between 3 and 9. You okay on that one? One more, and we're done. Okay, so we're going to work our way over until we get past the first inequality symbol. What would we do first to solve this? Add 6. Whatever I do to one side, I have to do to the other. But I also have to do that where I'm ignoring as well. Okay, so 12 plus 6 is 18. I don't have X by itself yet, so I have to start the entire process over again. So what am I going to do next? Okay, so divide by -3. Did you have another question? You're okay? Okay, so what happens when we divide by -3? We have to flip the sign. So how many signs are we going to have to flip on this one? 2. So this becomes a -6 is greater than or equal to X, which is greater than or equal to -10. So let's check. Is -6 greater than or equal to -10?
Yes.
Yes. It seems backwards. Negatives are backwards, right? Smaller number has to go on the left, which means a -10 is our smaller number. These both get filled in circles. Shade in between.